I want to share with you what is ahead for humans exploring in deep space. In the next 9.5 minutes, you'll experience a 25.5-day mission from rollout to recovery. Exploration Mission 1, the first integrated flight test of Orion, the Space Launch System, launching from America's spaceport, is about to unfold. This is just the first of many missions for our new deep space exploration system. We'll launch due east from the Kennedy Space Center at an inclination of 28.5 degrees to the equator. Upon completing the first orbit, we'll commit Orion to a lunar trajectory at the translunar injection burn, enter an outbound coast phase towards the moon. Upon arrival, fire the service module engine to enter a distant retrograde orbit. After spending some time in this orbit about the moon, we'll burn the service module engines again, targeting the Earth to return home, before splashing down in the Pacific off the coast of California. Rollout from the vehicle assembly building signals that launch is near. Sitting atop the mobile launcher, the crawler transporter moves along the crawlerway towards the historic Launch Pad 39B, located at the Kennedy Space Center, at a top speed of 1 mile an hour. After traveling over 4 miles, the rocket and spacecraft climb up a ramp and are positioned over a flame trench. The mobile launcher is lowered onto a support post, and the crawler is rolled away to a safe distance. Final checks are performed at the launch pad. The launch date is set, and the teams are prepared for the mission that is about to occur. It's sunrise on launch day. Engineers in the Launch Control Center have already powered up the spacecraft and the rocket and loaded the core stage with cryogenic fuel. As launch window open approaches, final checks are performed, and when all systems are go, terminal countdown is initiated. The big physics of launch are about to be put on full demonstration. Umbilical plates weighing hundreds of pounds await their cue to retract to clear the path of the rocket at liftoff, mounted on arms the size of tractor trailers. The mighty core stage engines are prepared for engine start, thermally conditioned for an onrush of cryogenic fuel in the heat of ignition. At T-minus 15 seconds, sound suppression is activated, cascading water into the flame trench to dampen the acoustic shock. And as the core stage engines achieve full throttle, shock diamonds appear. Then, booster ignition. The flame trench is flooded with fire. At first motion, the umbilical arms retract, and the tower is cleared in just seconds. At liftoff, the vehicle produces 8.4 million pounds of thrust and lofts a vehicle weighing nearly 6 million pounds and standing 32 stories tall to orbit. Propelled by a pair of 5-segment boosters and 4 liquid engines, it achieves a maximum dynamic pressure only 90 seconds into the mission, the period of greatest atmospheric force on the structure of the rocket. Thousands will gather in Florida to watch our ship get smaller and leave the Space Coast behind. In just 2 minutes into the mission, the flight boosters have consumed all their solid propellant and are safely jettisoned. The rocket will guide itself to orbit with magnificent precision. In just 3 minutes into the mission, we'll start to lighten load. The service module fairings are jettisoned, exposing Orion's solar arrays. In just 40 seconds later, the launch abort system is jettisoned. It is no longer needed. Orion could safely abort at any time. After consuming all the liquid fuel in the core stage in the 8-minute climb to orbit, the core stage engines are shut down. Following core stage separation, Orion will continue to orbit the Earth with the interim cryopropulsion stage. And along the way, they'll pass through the altitude of the International Space Station at 250 statute miles above the Earth. During this first orbit, Orion will deploy its solar arrays. It'll no longer need battery power. It could produce its own power. Following the solar array deploy, the arrays are positioned into a load-bearing position in preparation for the perigee raise maneuver. To ensure an Earth orbit, the thrust for the perigee raise maneuver is provided by the interim cryopropulsion stage. Once complete, final systems checks are performed on Orion, leading up to the translunar injection, or TLI burn. TLI lasts approximately 20 minutes and increases the spacecraft velocity over 9,000 feet per second, a speed change faster than a rifle bullet travels. The burn commits Orion to a lunar trajectory just 1.5 hours into the mission. Following TLI, The spacecraft adapter remains with the interim cryopropulsion stage and separates from Orion. The interim cryopropulsion stage performs a disposal burn before deploying 13 CubeSats, each with their own science and technology mission, using the extra volume and performance of the rocket. As Orion departs low Earth orbit, it flies through the orbital debris field encircling the Earth. It flies past the global positioning navigation satellites, past the communication satellites in geosynchronous orbit, and through the Van Allen radiation belts and into the deep space environment. Orion is entering an outbound coast phase, uniquely designed to navigate, communicate, and operate in this deep space environment. The outbound coast lasts 4 days. Upon arrival to the Moon, the service module will be used to perform a lunar gravity assist maneuver, allowing Orion to enter what's called a distant retrograde orbit about the Moon. At closest approach, Orion will be just 62 miles from the surface of the Moon, able to see distinct surface features, including individual craters. As Orion flies around the far side of the Moon, it will lose all communication back on Earth. Mission Control will await acquisition of signal, and as we lock on, a new generation will see their first Earthrise. The spacecraft is now in the distant retrograde orbit. We'll spend over a week in this orbit, testing the systems in the deep space environment, and along the way travel farther from Earth than any human-capable spacecraft has ever gone. At its farthest point will be some 1,000 times farther from Earth than the International Space Station at over 270,000 miles. Teams at Mission Control Houston and at Naval Base San Diego will prepare for Orion's return home. The recovery ship will set sail for the recovery zone in the Pacific as Orion exits the distant retrograde orbit with another service module engine firing. Along the way, we'll adjust our trajectory to target the Earth's thin atmosphere, ensuring a precision landing in the Pacific Ocean. Another 4 days coast home. As we approach the Earth, an important contribution by our European partners called the Service Module has done its job. It's about to be jettisoned. When the crew module separates from the service module, we'll orient the world's largest heat shield into the direction of travel. Entry interface is about to occur at an altitude of 400,000 feet. When Orion enters the Earth, it will hit the Earth's atmosphere traveling at a speed of 24,500 miles an hour and decelerate at 9 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the sun, approaching 5,000 degrees Fahrenheit. Orion will decelerate, pass through the sound barrier, and announce its arrival to waiting recovery team members with a sonic boom. After peak heating, a protective thermal cover over the parachutes, called the forward bay cover, will be jettisoned. This begins a series of parachute deployments. The drogue chute deployment is designed to stabilize and slow the spacecraft. In a period of less than 20 minutes, Orion will slow from a speed of Mach 32 to 0 at splashdown. As the 3 main parachutes slowly deploy, they bear the weight of the 22,000-pound capsule, allowing it to gently descend to a splashdown on the surface of the ocean. After 25 and a half days, and a total distance traveled exceeding hundreds of thousands of miles, a precision landing right near the recovery ship. Following splashdown, Orion will stay powered for 2 hours to collect data on how hot the cabin temperature got following re-entry. Navy divers, deployed from the waiting recovery ship, will approach in small boats. Initially, they'll inspect for hazards before hooking up tending lines and a tow line. The tow line will be used to pull the capsule into the well deck of the waiting recovery ship. As the capsule clears the stern gate, The stern gate will be closed, and the well deck will be drained, and we'll bring our ship home. And we'll do it all again with American astronauts on board on the very next mission. Be proud of what you're doing each and every day. Thank you for your contributions to this, the first of many exploration missions to come.